Hello, today we're going to learn about the future value of a single amount. The future value of a single amount is the amount of money that a dollar will grow at some point in the future. So if I invest a dollar today, what is it going to be in 3 years, 10 years, or whatever it is that I decide? Or if we look at our last video, we invested $1,000 for 3 years at 10%, and we need to calculate what is it going to be, what dollar amount is it going to be in the future. There's a formula to figure it out, and this is the future value equals capital I, which is the amount invested at the beginning of the period, also known as the principal amount. You can hear that referred to as that, times 1 plus little I, which is the interest rate per compounding period, to the nth power, which is the number of compounding periods. So let's just go, in the last video, we looked at simple versus compounding interest. And if you recall, compounding interest is when we earn interest or pay, depending what you have. But usually it's when we earn interest on the initial investment plus the interest to date. So if we invested $1,000 today, right, at the end of year one, assuming a 3-year investment, at 10%, we would have $1,100. At the end of year 2, we would take that full $1,100, which includes the $100 of interest, times 10% and add it to this amount, and we would get 1,210. Then we earn 10% on this $1,210, and we have a future value of $1,331. I'm going to go back into our Excel file that we used in the first video and just scroll up. And you can see here, this is what we did to calculate the compounding of 3 years at 10% manually, meaning in Excel, where we had, here's each period, and here's our 10% that we earn each period. So if we were to use the formula that we see right in here, we would put $1,000 and 1 plus 10% to the third power, right? We would get $1,331 at the end of that calculation. Just trust me on that math works. There is an easier way to calculate this as well. And this is when we introduce the concept of these factor tables. So you can also take this $1,000 times a specific factor, and it'll give you the same answer, my $1,331. Well, let's look at these tables. I'm going to go to the internet, and I'm going to go back. I just Googled in here, as I said, present and future value tables. And we're going to learn about present value in a different video. But it's just, there's all these different kinds, and I think I clicked on this one. It just PV and FE. I just clicked on that, and it gives you these tables. You see this says table 1, future value of $1, and over here you can see it has that formula of $1, meaning that's our capital I, or our principal amount, times 1 plus little I, which is our interest per compounding period, to the nth power, right? And you see this huge table, which I'll show you how to use. When you bring up tables, there are various tables for different things. This one is the future value of $1. If I keep scrolling down, I can see there's table 2, is present value of $1, which we'll get to in another video. And then I can keep scrolling down, a future value of an ordinary annuity of $1, and it continues to, there's 6 different tables shown here. It's really important that you use the right table for the computation you're trying to achieve. So when we are trying to figure out the future value of a single amount, this is the table we use, the future value of $1. Let's go back to my Excel right here, and I can see that my principal amount was $1,000. So let's figure out what amount of interest rate I have per compounding period and the number of compounding periods. Well, since I'm compounding annually, I have a 10% interest rate, and my number of compounding period is 3. I'm compounding once a year for 3 years. So my little I is 10%, and my n equals number of compound is my n equals 3. So let's go back to my table, my future value of $1, and I said n equals 3. N is listed down here in all these rows, and I look across the column for 10%. So here's n equals 3 and 10%. If I keep going straight across, here is 1.331. So if I look at my slide here, if it comes up, you take your principal amount right here, 1,000, times your fair value factor, a future value factor of $1 of 1.331, and I get to $1,331. So if I go back into Excel, this is that number right here. Let's continue looking at another example where I compound semi-annually. So this is the same problem where I invest $1,000, but now over 3 years, but invest semi-annually. It compounds semi-annually. So I have 6 compounding period, right? I have June 30th of year 1, 12/31 year 1, June 30th year 2, 12/31 year 2, June 30th year 3, 12/31 year 3. That gives me 6 different compounding periods. So my n equals 6. My interest rate is still an annual interest rate is 10%, but since I'm compounding twice a year, it ends up being 5%. So when I look at my factor table, I'm going to go n equals 6, I equals 5%. So let's go in here to my factor table. My n equals 6, and now my interest rate is cut in half because I do compounding twice a year. So I go to 5% is 1.3401. I hope you can see that right. Oops, right there. 1.3401. Let's go back here. So if I say equals $1,000, which was my principal amount, times 1.3401, I get my $1,340. So that's using the factors. Let's continue on just for compound quarterly. I want to show you, I made this mistake at first and I was like, why is this not working out? But when we compounded quarterly, right, that means that it says, the problem would say, if I invest $1,000 today for 3 years with quarterly compounding at 10%, how much would I have at the end of the 3 years? That's what the question would be. So compounding quarterly means 4 times a year. So it would be, let's just say we invested on January 1, we would compound on March 31, June 30th, September 30th, and December 31st of each year for the next 3 years. So my compounding periods is 12. Okay, so my n equals 12 in this situation. N equals 12. Now let's talk about our interest rate because we need our number of compounding periods and our interest rate to figure out what factor to use. And we say, at first I used 3% because that's just, I didn't round out enough, right? And it wasn't, my answer wasn't working and I couldn't figure it out. I was like, why is this not working? Because actually we use a 10% annual interest and we divide by 4 because we have 4 times a year where we compound the amounts. And so that actually gives me a 2.5%, right? So my little interest equals 2.5%. It's just that I didn't extend the decimal enough, so it looked like 3%, but it's actually 2.5 when I put it in the formula. So let's just see. My n equals 12, I equals 2.5. Let's go to my table. N equals 12, so I go right down here. And my interest is 2.5. So let's just go here. And so my factor is 1.34489. 1.34489. So I have equals $1,000 times 1.34489, I think it was. Yes. And so let me just make that, it's a little bit of rounding, but here's my $1,345, which is the exact amount I calculated when I did quarterly compounding. So back to our slide. Let me go up. Here, this one. And I'm saying this because it will make a difference for future videos. This is the formula for future value of a single amount. Okay, and so we can use this formula, or we can use the factor tables. However, sometimes we don't have all these amounts, and so then we cannot use a factor table, and we have to kind of back into what amount we're looking into, and we'll cover that in a different video.